Hello students, welcome to our maths class. I am Anoop Massey and I am the maths educator on this platform. Okay, here, before we start with the class, I would like to share with you that's what's new with the Unacademy. So here you can see Unacademy ask a doubt. So you get this feature over here to ask a doubt. Okay, you can ask unlimited doubts. You will be getting a high quality video solution in English and Hindi. You can obtain instant and accurate solutions of many questions. You can ask doubt at any time. Right? You can ask doubt at any time. You can receive exact matches for the questions. And get assistance with the homework also. Now these are the ways in which you can ask the doubts. These are the following steps given to you, so you can go along with these steps and ask the doubts. Okay, next, Unacademy Plus subscription features. These are the features that you will be getting. Okay, what else we have for you is you can use my referral code and you can get a discount of 10%. Okay. And my referral code is AMSIRUP. Okay, so let's see. Today we will be starting with the surface area and the volume of solids like cylinder, cone and spheres. Okay, so let's start with the first question straight away. So in the first question, it's given that a tent is in shape of a cylinder surmounted by a conical top. The height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter. Now, they say find the area of the canvas used for making the tent. Also, the cost of the canvas of the tent at the rate of rupees 500 per square meter. Okay, now let's see here in the figure. So, as you can see in the figure here, this is the slant height given to you. Now, as you can see, the cone and the cylinder both have the same radius. See, it's a surmounted figure, so that means the diameter is same, so you can say the radius is same. So if I talk about the cone, then I can say for cone, see here, the diameter is here, so the diameter given to us is height and the diameter is given 4 meter. So from here you can get a radius. So how much will be the radius? Radius will be half of it. So we can say that the radius is of 2 meter. Right. So first of all, what we can do, we can get here the radius we have got for both. Now we need to find the area of the canvas used. Okay, so you can say area of canvas, area of canvas used. Now see where the canvas will be used. I am highlighting it on the figure. Now for the conical portion, you can say that the canvas will be used on the curved surface area of the cone, which I am shading in green. So that means canvas will used on the curved surface area of cone. Okay, where else it will be used? Next, we can say canvas will be used on the curved surface area of the cylindrical portion, that as I am shading with yellow, right? So canvas will be used on these two surfaces. So which two surfaces? The one which is colored in green, that is the curved surface area of cone, and the one which is colored in yellow, that is the curved surface area of the. Okay, now so it's clear where it will be used. So you can say that the canvas will be used on curved surface area of conical portion plus it will be used on the curved surface area of cylindrical portion. So it will be used on the curved surface area of conical portion and the curved surface area of cylindrical portion. Okay. Now the curved surface area of conical portion. So the formula is pi r L, right? And the curved surface area of cylinder formula is 2 pi r and h. So we have curved surface area of conical portion plus the curved surface area of cylindrical portion. Now as you can see, before substituting the values, to make our calculation easy, the best way will be to take common. So here we can take pi common, and as you can see radius is same for both, so you can also take r common. So you will be left with L plus 2h. Okay, after this now we can substitute the values. So pi is 22 by 7, radius as you can see is 2. Within the bracket we will be having the slant height, and you can see the slant height is given 2.8, and then twice the height of the cylindrical portion. So you can see height of the cylindrical portion is 2.1. So 2 into 2.1. So if I solve this, this is giving me 22 by 7 into 2. Within the bracket I am getting 2.8 plus 4.2, right? So here if I solve it further, so I can say this will be 22 by 7 into 2, and within the bracket I am getting 2.8 plus 4.2, that will make it 7. So you can see this will cancel out. So you can say that the area of the canvas required will be 44. So here we have calculated what area of canvas will be required. That will be 44. Now what else we need? Also find the cost of the canvas at the rate of rupees 500. Now we have to find the cost also. Okay, so here I am finding the cost this side. So I am writing the formula for the cost. As you can see, cost is given 500 per square meter, and square meter is the unit of area. So we can say cost formula will be rate into area, right? So how much is the rate over here? Rate is 500. How much is the area? Area you have calculated 4400. So when you multiply it, 5420 carry over to 5420. So here the amount required will be 22,000. Hope this is clear to you now. So the tent was required, and as you can see in the diagram, we can see that the canvas required will be on the curved surface area of the conical portion. So we need to find the curved surface area of conical portion, as well as it is also required on the curved surface area of cylindrical portion. So we need to calculate curved surface area of cylindrical portion. So these are the formula for curved surface area of cone and the curved surface area of cylinder. And remember, to make your calculation easy, if you find something common, then take that common, and after that you substitute the value, so your calculation will always be easy for you. Hope this is clear to you. Now moving on to the next question. So let's see what's the next question we have. So next question we have: a vessel is in form of a hollow hemisphere. So see, this is the hollow hemisphere. A vessel is in form of a hollow hemisphere mounted by a hollow cylinder. A hollow cylinder over it. Now again you can see the two figures are surmounted, so that means their radius will be same. Right. So here the diameter is given. So if diameter is given, so the radius will be half of it. So we can write it here. The diameter given is 14 centimeter. So from here we can say that the radius will be 7 centimeter. Okay, now in this figure, see, this length is 14 total. So it will be 7 this side, 7 this side, because the radius is from center to circumference. So radius will be 7. Now if you see this portion, this is also the radius. See, this is for a hemisphere. This is also the radius. So from here to here, this is 7. Now, if I ask you, what about this portion? See, I'm just marking it with some other color. Okay, if I ask you from here to here, what will you call this portion? See, this portion. So you will say that this portion is representing the height of the cylindrical part. So I can mark it as h, that is the height of the cylindrical part, right? So this is h, height of the cylindrical part. And what about this? So this is the radius. You can say this portion is radius. So this is clear to you. Now, the total height of this vessel is 13. See, the total height of the vessel is 13, right? Now, if you look in the figure, then you will say that this total height is divided in two parts. See, one is h, the height of the cylindrical portion. The other one is the radius of the hemisphere. So this total height 13 is representing h plus r, right? So I can write h plus r is equal to 13. So this is clear to you. Now height, this h is the height of the cylindrical portion, that is unknown to us. Radius is known to us as 7. So from here I can get the height of the cylindrical portion, that is 6. So I've got the height of the cylindrical portion. Now the question says find the inner surface area of the vessel. So I have to find the inner surface area of the vessel. So see, inner surface area of the vessel. Now if we talk about the inner surface area, then see again we have two curved surfaces. Inner surface area, one is the curved surface area of this cylindrical portion, right? One is the curved surface area of the cylindrical portion, this one. This is the curved surface area of the cylindrical portion. So we need to find the curved surface area of cylindrical portion, and second we need to find the curved surface area of hemispherical portion. So if we combine these two, this will be known as total surface area, right? So let's find these two. So it will be curved surface area of cylindrical portion plus curved surface area of hemispherical portion, right? HS I am using for hemispherical portion. Okay, now let us write the formula for curved surface area of cylinder. So it's 2 pi RH, and the curved surface area of hemisphere formula is 2 pi r square. That is the formula for the curved surface area of hemispherical portion. Now again I told you, if you want to make your calculation easy, try to take common. See, 2 pi is common, as well as radius is also common because both have the same radius. So I can write 2 pi r and within the bracket h plus r, right? Now let's substitute the values. After taking common, it always becomes easy, the calculation. Radius is 7. Within the bracket h plus r. So h plus r means the total height. So straight away you can write 13, or you can write it like this also. This 7 will cancel out over here. So you are getting 44, and within the bracket you are getting 13. Now let's multiply it. Now 13 into 4 will give us 52, carry over 5. 13 into 4 will give us 52 and 5, 57. So curved surface area of the vessel, the total vessel, will be 572. So this is clear to you. Now let's move on to the next one. So let's see what we have in the next one. Okay, the next question says we have the adjoining diagram shows a hemisphere, right? The adjoining diagram is showing a hemisphere, and that hemisphere is surmounted by a conical block of wood. Okay, the diameter of their base is 6 centimeter each. Okay, so diameter of their base is 6 centimeter each. So both are having the same diameter. So here I can write diameter is equal to 6 centimeter. So I can say that the radius is equal to 3 centimeter. So here you can see radius will be same. The slant height of the conical portion, so this slant height, that is L, slant height of the conical portion is 5 centimeter. Slant height of the conical portion is 5 centimeter. Now first of all, they have asked us to find the height of the cone. Now you must be knowing this formula. This formula relates the three dimensions of the cone. Cone has three dimensions: slant height, height, and the radius. Right? There are three dimensions in the cone. So this is the formula that relates the three dimensions. So let me write this formula, and now let's substitute the values. Slant height is 5. Height of the conical portion we have to find. How much is the radius? Radius is 3. So when you solve it, you will be getting 16 is equal to h square. So height you will be getting as 4 centimeter. So height you are getting as 4 centimeter. So the first part says find the height of the cone. So we have got the height of the cone as 4 centimeter. Second part says find the volume of the solid. Now you need to find the volume of the solid, means you need to calculate volume of cone as well as the volume of hemisphere. So let's see, let me write it over here. Volume of solid. So volume of solid. The solid, as you can see, is composed of two parts. So what we will do, we will write volume of conical portion, right, plus volume of hemispherical portion, right. Okay, now let us substitute the formula. Volume of conical portion, we have the formula 1 upon 3 pi r square h, plus volume of hemispherical portion, we have the formula 2 by 3 pi r cube. This is the formula. So we have written this formula. Now here in the formula you can see 1 upon 3 pi r square can be taken common. So 1 upon 3 pi r square has been taken common. So here we are left with h, and here you are left with 2r. Remember, taking common will always make your calculation easy. Now here pi value is given as 3.14, so we will not be using 22 by 7. So it's given 3.14 into square of the radius. So radius is 3, so you will put square of it. So it will be 9, right? So 3 square, so we are going to put it 9. Within bracket we have h, that is the height of the cylindrical portion, sorry, this conical portion, that we have got 4 plus 2 into radius 3. So here this 3 will reduce 9. So you are left with 3.14 into 3, and from the bracket you will get 10. See, 3 to the 6, 6 plus 4, 10. Now let's solve it. So volume will be equal to, now this multiplied by 10 will give me 31.4. I have multiplied 3.14 with 10, so 31.4, and then multiplying it by 3. So 3 into 4 will give us 12. This will give us 4, 3, 3 is 9. So 94.2 centimeter cube. So what will be the volume? So 94.2 Hope this is clear to you. As you can see in this question, this solid, it is composed of two parts, conical part and hemispherical part. So I'm adding these two parts to get the volume of the solid. Okay, now moving on to the next part. We have question number 4 here. Let's see what's given in this question. The question says the surface area of a solid metallic sphere is this much. So this is the surface area given to you, and this is the surface area of a sphere. So let's see what can be calculated from the surface area. Surface area is given 2464. Let's write the formula for surface area. So it is 4 pi r square. So it is 2464. Now pi not given, so we are going to use it as 22 by 7. So it's 2464. Now let's cross multiply and we will get r square. So 2464 into 7 whole upon 4 into 22. So let's reduce it. 22 will reduce it. 22 1 are 22, carry over 2, 22 1s are 22, carry over 4, 22 2s. Then this 112 can be reduced with 4, 4 2s are 8, carry over 3, 4 8s are 32. So we are getting r square is equal to 28 into 7. So let's write it in the prime factorization form. So this can be written as 2 square into 7. 28 can be written like this and then into 7. So r square is equal to 2 square into 7 square. So from here you are getting radius. You will take square root, means these powers will be reduced to, and the radius will be coming 14 centimeter. You see, just check this. Is this clear to you? How we got the radius? Surface area was given to us, so we applied the formula for surface area. See, 4 pi r square, that is the formula for the surface area. So after getting the formula for the surface area, we have got the radius. Okay, the first part says calculate the radius of the sphere. The second part says, now they say that this sphere was melted and recast into the right circular cone. Should be right circular cones, not cone but cones, of radius 3.5 and height 7. Calculate the number of the cones. Now let me first of all tell you, see, this is a solid sphere, right? We have a solid sphere. Okay, so the question is saying that this solid sphere is melted and it is recasted into cones, right circular cones. So this is a, let us suppose this is a cone, and the question says it is casted into right circular cones. That means not only one cone but many cones were made from it, and each is having the same radius and the same height. So that means volume of all the cones will be equal. So let us consider the number of cones be n. So I multiply this side by n, because not only one cone was made but n cones. Now what this diagram represents, this diagram represents that volume of this sphere will be equal to volume of n cones, because from this solid sphere you have made these solid cones, not one cone but many cones. So what I do first, I will find volume of a sphere. Okay, so volume of a sphere. Just I will write the formula. Remember, I will not be substituting the value at this point, because later on, as you can see, I have to equate. So when I will equate their volume, then there will be cancellation of many terms that will make our work easy. So let's find volume of the sphere. So volume of sphere is 4 by 3, then we have pi and r cube. Remember, we are not going to substitute the value at this point. So first we have got volume of a sphere, right? Now we need volume of n cones. So first we will find volume of one cone. So volume of a cone. So one cone. So formula is 1 by 3 pi r square h. This is volume of one cone. Now as there were n cones, so you can write volume of n cones. So you can use it this way, 1 by 3 pi r square h into n, that is volume of n cones. So this much is clear to you. Let's see. First I got volume of a sphere, then I got volume of a cone, and as here I have considered that n cones were made, so I can find volume of n cones by simply multiplying it by n. Now this 1 represents the volume of a sphere. The second equation represents the volume of n cones. And remember, whenever you are casting one solid into another one, volume will be equal. So what we will do, we will be equating their volumes. So volume of n cones will be equal to volume of sphere. We will be equating their volume. Okay. So we have already calculated it in the form of formula. This is 4 by 3 pi r cube. Okay, now here, before substituting the values, see, you can cancel out pi both sides, this. You can cancel out upon 3 both sides, this. Okay, so now we will substitute the values. Now before substituting the values, now let me arrange it, and then you can substitute the value. It will be more easier. So n, so formula for n will be arranged like this: 4r cube upon r square h. Now in this formula, let me substitute the values 4. Now this capital R we are using for the sphere. So we need the radius of sphere that we have already calculated, 14 upon r square into h. So small r is representing the radius of conical portion. So the radius of conical portion is 3.5. And then into h, that is the height. So height is 7. Now you will be solving this equation, and let's see what you will be getting. So let me solve it for you. First of all, we can say I can reduce, this will give me 2. Now 3.5 will reduce 14 and give me 4. This again 3.5 will reduce 14 and give me 4. So I am left with 4 into 4 into 4 into 2. So let's see what will be my final result. So n is equal to 4 into 4 into 4 into 2. So 4 into 4, 16, 16 fours are 64, 64 into 2, 128. So the number of cones made will be 128. You see, is this clear to you? So remember this point over here which I have tried to explain you with the help of this diagram. Now see what I have tried to explain you here with the help of the diagram is this. I have tried to explain you this thing, that is, whenever you are casting a solid into another solid, then their volume should be equal. Now this was a solid sphere single, so volume of this sphere will be equal to, now here we have supposed that n cones were made, and as each cone was of same size, so we can say that volume of these n cones will be equal to volume of the sphere. So small v into n, that is, so always we are going to do it like this: volume of this body is equal to volume of the other body casted. Okay. Okay, now let's move on to the next question. So what we have in the next question is, now they say a spherical bowl of internal radius 9 centimeter is full of liquid. The liquid is to be filled into cylindrical shaped bottles, each of a radius 1.5 centimeter and height 4 centimeter. How many bottles are needed? See, the question will be like this: a hemispherical bowl like this. This is a hemispherical bowl, right? Now they say this is filled with some liquid, and now this liquid is to be transferred into cylindrical shaped bottles. So we have cylindrical shaped bottles like this, and now they are saying cylindrical shaped bottles, so that means more than one bottle will be filled, right? So we can consider n bottles. So I am going to make it into n. So same as we did in the previous question, that whatever will be the volume of liquid, now the liquid is filled in this, now this liquid is to be transferred in this bottle. So what you can say is volume of the liquid in hemispherical vessel will be equal to volume of liquid in these n bottles. So we can equate their volume. So see, first what I will do, I will calculate volume of this hemisphere. So let me calculate volume of hemisphere. Let me calculate volume of hemisphere. The formula for volume of hemisphere, 2 by 3 pi r cube. And remember, when you know that you have to equate their volumes later on, so no need to put the values just now. Let it be like this only, because later on we will be equating them and then many things will be cancelling out. Next we have volume of cylinder. So volume of cylinder. So cylinder is this. So it is pi r square h, volume of cylinder. So this is volume of a cylinder and there are n cylinders. So we can write volume of n cylinders is equal to volume of one cylinder multiplied by n. So that will give us volume of n cylinders. See. Now, as I said, these two volumes should be equal because whether you cast from one solid to another or whether you transfer a fluid from one container to another, volume should be equal. So we are going to equate their volume. So I can write volume of n cylinders will be equal to volume of M.Sc, right? So on the left side, volume of n cylinder is this pi r square h into n, and on the right side, volume of hemisphere is 2 by 3 pi r cube. So we have equated them. Now, before substituting the values, you can see over here, we can reduce pi both sides. So let's reduce it before substituting the values. And now we will be substituting the value. Now on the left side, we need radius and height of the cylindrical portion. So radius is 1.5. Radius is 1.5 and the height is 4. On the right side, we have 2 upon 3 into r cube. Now this is the radius of hemisphere, and you can see the question, the radius of hemisphere is giving us 9. Now before cross multiplication, first of all I am going to reduce this S3. So let's see what will be n here. So n is equal to 2 into 9 into 9 into 3. So 2 into 9 into 9 into 3 upon then 1.5, 1.5 and 4. We have 1.5 into 1.5 into 4. Now when I reduce 9 with 1.5, see, now let's do the reduce it over 1.5 will reduce 9 how many times? 6. 1.5 will reduce 9 how many times? 6. This 2 will reduce 4 how many times? 2. And then this 2 will reduce 6, 3. So finally what we are left with is n is equal to 3 into 6 into 6. 3 into 6 into 3. So we have 6 threes are 18, 18 threes are 54. So the number of bottles filled will be 54. Just see if you have any doubt in this, you can comment in the chat box. This much is clear to you. Okay. Now let's move on to the next question. Question number 6. Now let's see what we have in question number 6. They say a hollow sphere of internal and external radii. A hollow sphere whose internal radius, so let the internal radius be represented by small r, 6 centimeter, right? External radius represented by capital R. Now this hollow sphere is melted and recast into small cones of radius 2 and height 8. So see, the question is like this. Let me explain you with the help of a diagram. They are saying we have a hollow sphere, right? Like this. It's a hollow sphere. So we have material only on this portion. It's a hollow sphere with internal and external radii known to you. Now the question says that this hollow sphere is melted and it is recast into small cones. So now they are saying it is recast into small cones. So that means not only one cone but many. So here small cones and volume of, now let us suppose that there are n cones. So we will make it into n. So here according to this diagram, this explains that whatever will be the volume of this material in a hollow sphere will be equal to volume of these n cones. Now for this, let us see this one. Radius known to us both. Small radius is 6 centimeter and capital R as 8 centimeter. Now coming for this portion here, this is a cone, and in cone we have been given the radius as 2 and height 8. So radius given is 2 and height given is as 8. Right. Now the question says we have to find how many such cones can be casted. Okay. So let's do the thing. Here I've already written this here. So okay. Now so first I need to find the volume of material. Now so you cannot say volume of this of this hollow sphere. You will say material in this hollow sphere. So let's find volume of material in hollow sphere. Now what's the formula for volume of material in the hollow sphere? So formula is 4 by 3 pi, and within bracket we have r cube minus r cube. This is the formula for volume of material in hollow sphere. Okay, next we need volume of a cone. So volume of a cone. So formula is 1 upon 3 pi r square h. But as you can see that we have supposed that n cones were constructed. So we can get volume of n cones. So whatever we got the volume of one cone, that will be multiplied by n and we will get volume of n cones. So this is your second equation. This one was your first equation, right? Now these two must be equal because one material of one shape is being molded and casted into material for the other one. So it will be same. So equating these two. So we are going to equate volume of n cones with volume of material in hollow sphere. We will be equating these two. So let's equate them. Volume of n cones is this, and this will be equated with volume of material in a hollow sphere, that is 4 by 3 pi r cube minus r cube. Now before substituting the values, you can see over here that this pi upon 3 can be cancelled out. So we have cancelled it out. Okay, now we will substitute the values. Now here it is r square into h. So this is the radius and height of the cone. So you can see radius and height of the cone 2 square and the height is 8. On the right side 4. Now this is in external and internal radius of hollow sphere. They are 8 and 6. On the left side we have 4 into 8, 32n. Now on the right side, as I told you, taking common will always make your calculation easy. Now you can see from these two, you can take 2 cube common. So I am taking 2 cube common. So here I am left with 4 cube and here I am left with 3 cube. Now see, whenever I take common, my calculation becomes easy. So on the left side, it is 32n, and on the right side you see 4, and this 2 cube will give you 8. So 4 into 8 will give you 32. And here I have 4 cube 64 minus 27. Now again you can see here on the left side and on the right side this 32 can be reduced. So I am getting value for n, that is the number of cones. 64 minus 27. So the number of cones coming is 37. So this will be my answer. The question says find the number of cones cast. So number of cones casted were 37. Okay, so let's move on to the next one. Now in question number 7, see what they are saying. Question number 7 says a container shaped like a right circular cylinder. So here we have a container. The shape is a right circular cylinder, right? Like this. So a container with the right circular have a diameter. Now diameter of this is given as 12. Now if diameter is 12, you know you will take half of it, and this will be the radius of cylindrical portion, 6, and height is 15. So this we know about the cylindrical portion. Now they say this is full of ice cream and this ice cream is to be filled into cones. Now this ice cream is to be transferred into cones like this, having a hemispherical shape, and now these cones have hemispherical shape like this. So this is the diagram, and now they say how many such cones, that means how many such ice cream cones will be possible. So let it be n. See, first try to understand this. This was a cylindrical container. Okay, this cylindrical container was full of ice cream. Okay, the cylindrical container was full of ice cream. Okay, so whatever will be the volume of ice cream. Now they say this ice cream is transferred into cones. So first you are filling up the cone, and then on the top of the cone you have hemispherical shaped ice cream like this. So that means here the ice cream in this was given two shapes, conical and then above it hemispherical. Now you can see that cone and hemisphere, they are the surmounted one. Cone and hemisphere, they are surmounted one, so their radius will be same. So if radius of cone is given, so same will be the radius of hemisphere, or if radius of the hemisphere is given, same will be for the cone. Now let's see what's given. The ice cream is to be filled into cones. Height of the cone is given as 12. Okay. So height for this cone, they are saying height of the cone is 12 and the diameter is 6. So radius will be 3. Now here, whatever will be the radius for this conical portion, same will be the radius for hemispherical portion also. They are the surmounted figure, right? So they will be having the same radius. Now here what we have to do, first we will find volume of this cylindrical portion. Okay. So volume of cylindrical container, right? Volume of cylindrical container. So formula is pi r square h. Now remember, when you have to equate the volumes, then there is no need to substitute the value just now. Now, we need to find volume of this ice cream, which is in shape of cone plus hemisphere. So volume of ice cream in cone. Now volume of ice cream in cone means volume of conical portion plus the volume of this hemispherical portion. You will have to consider both, remember, not one, but you have to consider both of them. So you will write volume of conical portion first. So this is 1 upon 3 pi r square h, plus there is a hemispherical portion also. So 2 by 3 pi r cube. Right. So this is your second one. Now this is in a cone. Now, not this won't be the second one because this is of one ice cream cone only. And we have how many ice cream cones? So we are going to write volume of n ice cream cones. So what you will do, you will multiply it by n. See, this is for one ice cream cone, right? You will multiply by n, see, like this, into n. Now, this will be your equation number 2. As we know that here volume of this ice cream in the container and the volume of ice cream in the cone into n cones must be equal. So let's equate them. So 1 upon 3 pi r square h plus 2 by 3 pi r cube multiplied by n is equal to pi r square h. We are equating them. Okay, now before substituting the values, let's see what can be taken common from the left side. Pi, radius is same, so r square can be taken common upon 3. So on the left side, I am taking pi upon 3 r square common. Pi upon 3 r square. So here I am left with h plus 2 r into n, and on the right side it is pi r square h. Now before substitution of the values, see, this pi can be cancelled out. So we have cancelled out pi. And now let us substitute the values here. This r stands for conical portion. So radius is 3. So 3 into 3. And then we have upon 3. Within the bracket, now this is height of the conical portion, that is 12. Height of the conical portion, that is 12, plus 2 into radius of the conical portion, that is 3, into n. On the right side we have the radius of cylindrical portion, which is 6, into height of the cylindrical portion, that is 15. Now let's see, the left side is giving me this 3 and 3 will cancel out. So left side, outside the bracket I have 3, and within the bracket this will be 12 plus 6, that is 18, into n. On the right side it is 6 into 6 into 15. So let's see what will be n. 6 into 6 into 15 upon 3 into 18. So let's see how can it be reduced. So this 6 will reduce this 3 times, right? This 3 will reduce 6 2 times. This 3 will reduce this 5, 15 5 times. So we are left with 2 into 5. So finally we can say that the number of ice creams will be 2 into 5, that is 10. So the question says find the number of such cones. So we have considered the number of cones as n. So 10 cones will be filled. Hope this is clear to you now. Now let's move on to the next one. Now the next question says that 504 cones. So see, this is one cone and they are saying 500 cones, 504. So multiplied by 504. So this will give me volume of 504 cones. So this is one cone. I am multiplying it by 504. So this will give me volume of 504 cones. Now what about the cones they are saying? The diameter is 3.5. Okay, so for this cone, diameter is 3.5. That can be written as 7 upon 2. So what will be the radius? So you will say half of the diameter. So when diameter is divided by 2, that will give you 7 upon 4. So for the cone, radius is 7 upon 4 and the height is given as 3. Height is given as 3. Now they are melted and recast into a sphere. Now these cones are melted and recast into a single sphere. And about this single sphere, they are saying you have to find the diameter of this sphere. You need to find the diameter of this sphere. Now see, this is the question. Now let's try to understand this question. The question says that there were 504 cones. So this is one cone multiplied by 504 cones. Now all these cones were melted and casted into a single sphere. So I told you whenever there is a casting or transferring of a liquid from one container to the other, volume has to be equated. So here we have to equate volume of these two. That volume of 504 cones will be equated with volume of sphere. So first what we will do, we will find volume of a cone. So the formula is 1 upon 3 pi r square h. But as there are 504 cones, so we can find volume of 504 cones. That will be 1 upon 3 pi r square h into 504. So this is volume of 504 cones, our equation number 1. Then we will be finding the volume of a sphere. Volume of a sphere, that will be 4 upon 3 pi r cube. As I have to equate the volume, so I am not going to substitute any value at the present time. I will substitute the values at the last when I have equated them. So let's equate them now. So volume of a sphere is equated with volume of 504 cones. So let's equate them. So 5 is cancelled out, upon 3 is cancelled out. 4 into, now r cube, this we have to find, right? So let it be written like this. Now on the right side, the radius and height of the cone. So radius is 7 by 4. So 7 by 4 into 7 by 4 into height. Height is also known 3, and then into 504. So let's solve it. So what will be r cube? In the numerator part we have 7 into 7 into 3 into 504. In the denominator part we will be having 4 into 4 into 4, right? Now let's reduce it. Okay, so see how can it be reduced. Let's start reducing it with 4. We can write 4 ones are 4, carry over 1, 4 twos are 8, carry over 2, 4 6 are 24. Am I going correct? 4 ones are 4, carry over 1, 4 twos are 8, 2, 4 6 are 24. Now it can be reduced with 2 now. So 2 on reducing with 2, 6 are 2, 3 are. Now it cannot be reduced further. Now see what we are going to do, how we are going to solve it. Okay, left side we have r cube. Now we have to take the cube root. It cannot be reduced further. Now see, this is 7 square, right? Then we have into 3, 7 square into 3. Now 63, prime factorization of 63. So that can be written as 3 square into 7. And in the denominator place, 4 can be written as 2 square into 2. Okay. So r cube is equal to, this will give you 7 cube and 3 cube. upon this will give you 2 cube. Now if I take the cube root, so I am getting the radius. So these cubes will be cancelled out, so it will be 3 into 7 upon 2. That is 21 upon 2 centimeter. That is the radius I have got. Hope this much is clear to you. But the question says find the diameter. So let's find the diameter. So here only I can find the diameter. So the diameter will be twice of the radius. So twice of 21 upon 2. So it will be 21 centimeter. So see, I have got the diameter. First I got the radius, and then the double of the radius will give me the diameter. Okay, the second part says, and I also have to find its surface area. I have to also find the surface area of this sphere. So I am rubbing this portion because this I have already explained you. This is the diagram portion, so I am rubbing it. And here I am going to calculate. Okay. So I am rubbing this, and here we can for just go through this solutions one again and comment in the chat box if you have any confusion regarding any solution. Right. Okay. So now we have to find the surface area of the second part says find surface area of a sphere. We have to find surface area of a sphere, and the formula is 4 pi r square. This is the formula 4 pi r square. Now let's substitute the values here. Pi is 22 by 7, and the radius we have got 21 upon 2. Now let's see what can be reduced. First of all, 2 into 2, 4. It will be reducing this 4. 7 will reduce this 3 times. So what we are left with is 22 into 21 into 3. So it's 22 into 63. So multiply 22, 63. So first multiply by 6. So 1, 2, 6. 1, 2, 6. So it's 1386. So we can say that the surface area will be 1386 centimeter square. Hope this much is clear to you. Any confusion? You can comment me in the chat box if you have any confusion. Now let's see question number 9. What's given in question number 9? Let's see what question number 9 has to say. The question number 9 says a sphere of diameter 12 is dropped into a right circular vessel. Now, right circular vessel means a cylindrical vessel filled with water, partly filled with water. So, see, starting of the question is like this. We have a sphere, okay, we have a sphere, and we have a cylindrical vessel which is partly filled with water. Suppose it is filled with water up to here, right? It is partly filled with water, and about the sphere, diameter is 12, so you can say radius is 6. Diameter is 12, so you can say that the radius is 6. Now this is partly filled with water. Now what they say, a sphere is completely submerged in water. See, now if you submerge this sphere in water like this sphere is submerged in water. So what you will find the rise in level of water. That means if water was up till here, then it will be seen up to here. So this portion which I am shading here now, this is the rise in level of water. Okay, now let's see the next question. In question number 10, they are saying a vessel is in form of an inverted cone. Okay, so let us consider a vessel which is in form of an inverted cone. So it will be like this, an inverted cone like this. You can take it, a vessel in shape of an inverted cone. Now they are saying its height is 8, so height of this conical vessel is given as 8 centimeter, and the radius of its top is given as 5 centimeter. So they have given us the radius and the height of this vessel. Now they are saying it is filled with water. Okay. So we consider it to be filled with water. Right? It is filled with water up to the brim. That means it is filled with water up to the top here. It is filled with water up to the top. Now the question says that when lead shots, each of which is a sphere of radius 0.5, are dropped into this vessel. This should be into the vessel. Right? So the lead shots are dropped in it. Lead shots means which are spherical in shape, so you can say many spherical balls were dropped in it. Now what they are saying about this, about these spherical balls. So about these spherical balls, they are saying that their radius is 0.5. So radius is 0.5 centimeter. Now this is the radius of these spherical balls, or you can write it 1 upon 2 centimeter, that is the radius. Now they are saying find the number of lead shots dropped. So let the number of lead shots be n. Let the number of lead shots be n. So we have considered the number of lead shots as n. Now because of these n lead shots, they are saying 1/4 of the water overflows. Right? So because of these n lead shots, 1/4 of water overflows from the vessel. So we can say that volume of these n lead shots will be equal to the volume of water overflown. So we can say that volume of these n lead shots will be equal to volume of the water overflown. So let's see. First of all, we will find volume of these n lead shots. So volume of a lead shot, that is volume of a sphere, that will be 4 upon 3 5 r cube. Now how many lead shots we have considered? N. So volume of n lead shots, 4 upon 3 5 r cube into n. So we have got volume of n lead shots. This. Now because of these n lead shots, how much volume of water overflows? So they say volume of water overflown is equal to 1/4 of conical vessel. 1/4 of conical vessel. So we can write it like this: 1/4 and then conical vessel volume. So formula is 1/3 pi r square h. This will make it equation number 2. Now we have to equate these two. We have to equate these two. So okay, now I am running it over from here, because we can note it somewhere here that for vessel, that is for cone, we can note the readings here, that for cone height is 8 and radius is 5, and for sphere radius is half. Now I am running it from here. So let's see how we are going to equate these. Okay, now let's equate these two. So how we will be equating? We will be equating these two. Volume of n lead shots is equal to volume of water overflown. So I will use some other color for this, so it won't get mixed up over here. Okay. So I have 4 upon 3 pi r cube into n equated with 1 upon 4 into 1 upon 3 pi r square h. Now let's see, before substituting the values, you can see pi will cancel out, upon 3 will also cancel out. Now we are going to substitute the values. So let's substitute the values. On the left side we have 4 into this r is for sphere. So sphere radius is 1/2. So this will be 1 by 2 into 1 by 2 into 1 by 2 into n. So here we have, so it's 1 upon 4 into radius 5 into height 8. Right. So let's see what can be reduced over there. So first of all, you can see 2 twos are 4. This will reduce it. On the right side, this 4 is going to reduce 2. Okay, now all have been reduced, whatever can be reduced. Now we have to find n. So n is equal to, we cross multiply this 2, so this is 5 into 5 into 2 into 2. So finally you can say that 100 spherical lead shots were dropped into the vessel. So the question says how many lead shots were dropped into the vessel. So we can say 100 lead shots were dropped into the vessel. Let's move the next one. So in the next one we have a solid wooden toy is in form of a hemisphere surmounted by a cone. So we have a wooden toy in form of a hemisphere. Okay. So let's consider this as a hemisphere surmounted by a cone, and then we have a cone above it. Now as these two figures are surmounted, so the radius will be the same. So the radius given is 3.5 centimeter. So radius for cone as well as hemisphere both will be same. So common radius you can say 3.5 means 7 by 2 centimeter. And they have given you the total wood used in making, that is the volume of this toy is given 166 whole number. So let's see here, volume is given first of all. Now this is the volume of this whole toy. This whole toy volume is given 166 whole number 5 upon 6. So when we reduce it into improper fraction, so that will be 1001 upon 6. So this is the volume. Now this is the volume of cone plus hemisphere. So here we can write volume of toy is equal to volume of cone plus volume of hemisphere, right? Okay. Volume of toy, that is already given to you. So later on we will put it. Volume of toy. On the right side we have volume of cone, so its formula is 1 upon 3 pi r square h, plus then we have volume of hemisphere, so formula is 2 by 3 pi r cube, right? So now volume of toy is already known to us, 1001 upon 6. Now on the right side I told you that before substituting the values, if you can get common, so try to get common here. Okay, so here you can see you can get common. So what you can get common is pi upon 3. First of all, you can say you have got pi upon 3 common, right? What else you can get common? You can get r square common. So I am getting r square common. So I am left with h plus 2r. So it is 1001 upon 6. Now on the right side, now let me substitute the values. Pi is 22 by 7, okay. Then in the denominator place we have upon 3, okay. Then we have r square. In the numerator place it is r square. Radius is 7 by 2. So you can write 7 by 2 into 7 by 2. And then within the bracket I have h, that is the height, and height we have to find of this conical portion. Height is unknown, and then we have twice the radius, twice of 7 upon 2. So on the left side I have 1001 upon 6. Now on the right side, let's see before opening the bracket what can be reduced over here. You can see this 7 will reduce 7, okay. This 2 will reduce this 22, okay. So what I can write here is 7 upon 6, and then within the bracket I am getting h plus 7. This is 11 is also there, 11 into 7. So straight away I can write 77, right? This was 11 into 7, so I can write 77. 77 upon 6, and then this. Now you see this upon 6 and upon 6 can be reduced when you cross multiply. This 77 will be cross multiplied over here. So you will be having 1001 upon 77 will be cross multiplied, and on the right side you have h plus 7. Now let's reduce these. So when we are reducing it by 11, 11 7 the 11 9 the 99, 11 1 the. Then again you can reduce it by 7, 7 1 the, 7 2 1, 21. So on the left side you are left with 21, and on the right side it is h plus 7, right? No, this is 7, not 21, sorry. Calculation wrong here. This is 7 1 the 7, and 7 3 the 21. So sorry, this is 13. So height will be 13 minus 7. So height will be 6. Now this height h, this height is for the conical portion. So we have got the height of conical portion. Remember, this h is representing the height of conical portion. So we have got the height of conical portion. But what the question says, find the height of the toy. You have to find this total height. This total height. See. So total height of the toy. Now you can see toy is composed of these two. Total height will be height of the conical portion plus this radius. So that will give you the total height. So height of cone plus radius of hemisphere. So height of cone we have calculated here, see 6, and radius is known to us as 7 upon 2. So 6 plus 3.5, so that will make it 9.5 centimeter. See, is this much portion clear to you? How we have got the height of cylindrical sorry, the height of the toy. First we got the height of conical portion. Volume of the toy was given. So from the volume of the toy, we have calculated height of the conical portion. And then the height of the conical portion is added to the radius and we get the total height of the toy. Then we are getting the total height of the toy. Hope this much is clear to you. Okay. Now we will move further and what they have asked in the next part. Also find the cost of painting the hemispherical part. Now we have to find the cost of painting only the hemispherical part, this hemispherical part. So we need to find the surface area of the hemispherical part. Okay. Let me make some space over here. I am going to remove this. This is of no use now. Now I need to find the cost of painting the hemispherical part. So for that I need to find first of all the surface area of the hemispherical part. Okay, so second part I am doing here, surface area of hemisphere, that will be equal to 2 pi r square, right? This is the formula for the surface area of hemisphere. So let's substitute the values. 2 into 22 by 7, and how much is the radius? 7 by 2 into 7 by 2 r square. So let's see what will cancel out here. This 7 will cancel out, 2 will cancel out, this 2 will reduce this 11. So you can say that surface area of hemisphere will be 11 into 7, that is 77. So we have calculated the surface area of hemisphere. Now we have to find the cost of painting it. The cost of painting. So how will it be done? So to find the cost of painting, area multiplied by the rate. We will multiply rate and area. So rate is given 10 and area you have calculated 77. So this will be rupees 770. So this will be the cost of painting it. Hope this much is clear to you. Okay, now let's move on to the next question. The next question says, a toy is in shape of a right circular cylinder with a hemisphere at one end and a cone at the other end. See? So let's see what type of a toy they have given us. This toy is circular cylinder. In the middle portion, it is a circular cylinder like this. The middle portion of the toy is a cylindrical portion with the hemisphere at one end. At the one end, it is having the hemisphere and cylinder and a cone on the other end. On the other end, it has cone. So the toy is like this. Three portions: hemisphere, cylinder, and cone. Now, as these are the surmounted figures, so that means the radius will be same for all of them. Now the question says height and the radius of the cylindrical portion. Now this is the cylindrical portion. Its radius is given, height and radius is given. Radius is given as 5 and height is given as 13. Okay. So height is given 13 and the radius is given 5. Now remember, these are the surmounted figure, so that means the radius of all will be the same. So if they have given you the radius for cylindrical portion, so same will be the radius. Now the radii are the same. Calculate the surface area of the toy if the height of the conical portion is given. So height of this conical portion, this height of the conical portion is given as 12. And they have asked us to calculate the surface area. Now the surface area of the toy. To calculate the surface area of the toy, what we need to calculate is, we need to calculate surface area of hemisphere. See, surface area of hemisphere plus surface area of cylinder plus surface area of cone. So I need surface area of these three parts: hemisphere, cylinder and cone. Okay. So when you need, now let's write the formula. Surface area of hemisphere is 2 pi r square. Surface area, curved surface area, right? All these are the curved surface area. Now we need the curved surface area. So for hemisphere it is 2 pi r square. For cylinder it is 2 pi r h. And for cone it is pi r l. So as you can see, we need the slant height of the cone, and the slant height of the cone is not known to us. So let's do the calculation here. Now when we are talking about the cone, you will say radius of all are same. So radius of cone is 5. Height of cone is given to you 12. So from here you can get the slant height. This is the formula. So in this formula, let us substitute the values. So L square is equal to 169. So L is equal to 13. Okay, now coming to this part. As you can see here, you can take pi and r common. So let's take pi and r common before substituting the values. So it's 2r plus 2h plus L. Now you substitute the values. Pi will be replaced by 22 by 7. Radius will be 5. Now within this 2r, so you can say 2 into 5 plus 2h, so 2 into 13 plus the slant height that we have calculated, 13. So this is coming 22 by 7 into 5, and within the bracket this is 10 plus 26 plus 13. So that makes it 22 upon 7 into 5 into 49. Now this can be reduced by 7. So you will get 110 into 7. So all over this will be 770. Sorry, 770. 770 centimeter square. That will be the surface area. So this is clear to you now. So we have done the 12th one. Now moving on to the next question. We have question number 13. Now what the question number 13 says. Question number 13 says, From a circular cylinder of diameter 10, now this is a circular cylinder, right? Okay, they are saying diameter is 10, so we can say as the diameter is 10, so radius is 5 and the height is given 12. Now they are saying a conical cavity. So from here a conical cavity is cut out of base radius and same height. Same base radius, same height. So let me draw a conical cavity which is of same base radius. So if I draw a cone, so its radius is same, so it's going to coincide with this circular portion, and then of the same height, so height of the cone will reach up to the height of cylinder like this. So this is the conical cavity that has been cut out from here. Now the question says what you, so see, same radius, same height, so that means radius for both is same, height for both is same. Now the question says find the volume and the surface area. Now how to find the volume of the remaining portion? So first what we will do, we will calculate volume of cylindrical portion, volume of solid cylinder, it's pi r square h. So let the pi be as it is. We will substitute pi in the last, right? Because during decimals we will substitute it in the last. Now we need radius. Radius is 5 into h. Height is 12. So this will give you 305 centimeter cube. This we have got volume of cylinder. Now of we will calculate volume of cone. As the conical cavity was cut out, so let's calculate the volume of cone. 1 upon 3 pi r square h. So again, I'm not going to substitute value for pi here. So it's 5 square. Radius is same. Height is also the same. So this will give me 100 pi. So see, first I calculated volume of cylinder hole. Then I calculated volume of cone. And now I'm going to subtract these two and I will get the volume of this remaining portion. This is the remaining portion which I have shaded blue. So I have to get the volume of this remaining portion. So volume of remaining solid. So how will we get that? So from volume of cylinder, I will subtract volume of cone. So let's see. So volume of cylinder is 300 pi and volume of cone is 100 pi. So the remaining volume is 205. That's the volume of remaining solid. See, it was a cylindrical portion, and from the cylindrical portion, a conical cavity was cut. So what I can do is from the volume of cylinder, I can subtract the volume of cone. So from the volume of cylinder, I will subtract volume of cone. So this I am getting the remaining, and now I will substitute the value of pi. 200 into 3.14. So 26, 2 4s are 8, 2 1s are 2, 2 3s are 6. So 628 centimeter cube. So this will be the volume of the remaining portion. Hope this much is clear to you. How to find the volume of the remaining portion. Next they say find the volume and the surface area of the. Now how many surfaces can you see? If I talk about the surfaces, see, you will say you can find the surface area of a cylinder because cavity has been made inside. So from outside, it's still the surface area of cylinder. So that is 2 pi rh. This is one surface. From above, it's still a circle. So it's pi r square. But a cavity has been made inside. So from inside, if you look at inside, then inside you will be finding the curved surface area of a cone, which is pi r l. So inside you will be finding the curved surface area of cone. So altogether, if a cavity has been drilled in the cylinder, so we can say three surfaces are left. One is the curved surface area of the cylinder from outside, one is the circular portion, and from inside, if you look, it's curved surface area of cavity, which is conical in shape, so pi r l. So that means to calculate this, first of all, radius slant height is needed. Okay, so let's calculate the slant height here. L square is equal to h square plus r square. So L square is equal to 12 square plus 5 square. So L square is equal to 169. So the slant height is coming 30. Okay. Now I'm going to calculate the surface area. Right? Surface area of remaining portion. So there are three surfaces I've explained you over here. So I'm going to add those three surfaces. 2 pi rh one, pi r square the other one, and pi r l the third one. Now before solving, remember you can take common. So you can take pi r common from here. So I'm taking pi r common. So I'm taking pi r common, it is 2h plus r plus l. Now let's substitute the values, or in the last I will substitute the value for pi. I'm not substituting pi here just now. So let pi be as it is. How much is the radius? So radius is 5. So pi into 5 outside the bracket. Inside the bracket it is 2h. So 2 into 12 plus capital R. So it's 5 plus capital L, that is 13. So it is 5 pi. Then we have 24 plus 5 plus 13. So altogether it is 5 pi, and within the bracket what you will be getting 5 pi, and within the bracket it is coming 24 plus 5, 29, 39, 40, 42. So 5 pi multiplied by 42, so 210 pi centimeters square. This is the surface area. Now substitute the value. This calculation carried over here. The surface area is equal to 210 pi. So surface area will be 210 into 3.14. So let's multiply it. So it's coming 600. Let's multiply it. The decimal will shift one place, so it will become 21 into 31.4. Okay. So 21 into 4 will give you 84. Carry over 8, 21, 20 and 8, 9, carry over 2, 21 into 3 are 63 and 2, 65, so 659.4. So this will be the surface area. So see how we have done this question. They have asked us to calculate. So now I think yes, this is the last question.